Are there any stars that aren't in galaxies? Are active galaxies and supermassive black holes dangerous? And did we recently find Dyson spheres? All this and more in this week's Question Show. Welcome to the Question Show. Your questions, my answers. As always, wherever you are, if a question pops in your brain, just write it down in the YouTube comments and I will gather them up and I'll answer them here. However, this is the last episode of the Question Show before we take our 2-month hiatus, our summer break. And so we won't be doing a show next week. It's going to be 2 months. We'll be back in early September. We're still doing a lot of our other shows on the channel, but the live streams and the question shows, we take a break in the summer. So go ahead and ask your question and maybe I'll answer them in the YouTube comments. All right, let's get into the questions. Dawn Guns. Hey Fraser, are there any stars that are without a parent galaxy that we've observed thus far? Absolutely. There is a whole classification of stars that are known as intergalactic stars or field stars, and these are stars without a galaxy, and they have absolutely been seen. And in fact, they can be seen both around the Milky Way as well as in between galaxies, as well as when you see galaxies that are interacting and they're throwing out these sprays of stars in their tidal tails, those are future intergalactic stars. And that gives you a bit of an insight into the sources of these stars. And there's a few. So the first one is they're thrown out during galaxy mergers and collisions. That a galaxy is really just a collection of particles. And so when you've got all of these particles that are coming together, and you've got all of these three-body interactions with all of the various parts of the galaxy, you get these amazing tidal tail sprays that throw out into space. And if the tidal tail is going at greater than the escape velocity of the combined galaxy merger, then those stars are on an intergalactic trajectory and they are gone. Now, they might end up in some other galaxy, and it's believed that there are stars that are already being transferred between the Milky Way and Andromeda. So there must be stars in the Milky Way that came from other galaxies. But others, if they're not going to interact with the galaxy at all, they're just flying off into intergalactic space. The other thing is hypervelocity stars that are ejected out of the galaxy. And so we know that there are dozens of stars that have been found so far that are being ejected out of the Milky Way right now. There are a few causes to this. One is interactions with the supermassive black hole at the heart of the Milky Way. You can have some kind of three-body interaction and a star can be kicked out. And as long as it exceeds the escape velocity of the Milky Way, then it's not going to come back. And the other thought is that you can have supernovae where you've got two stars that are orbiting around each other, and then one detonates as a supernova and essentially disappears. And now the other star is like on a slingshot and it gets fired out of the galaxy. And then the third idea is that you could have stars just form in intergalactic space and have never been part of a galaxy. So imagine if you have, we know we have regions of star formation that are found inside the Milky Way, but imagine if you had a region of star formation that was found just out in intergalactic space. Now, it would have to be fairly massive because it would have to have been able to pull together. And there would need to be some kind of event that would trigger this gas cloud to start collapsing, like maybe a supernova nearby, and this will lead into the next question, but I'll give you a hint of it, which is that galaxies can actually fire jets of material out into space from the supermassive black hole. That could hit one of these pockets of gas and that could trigger star formation. It could form a bunch of stars. The stars could be interacting in a cluster and eventually just break away from each other and then just start to float off into the universe. And so it's believed that a fairly large percentage of the stars in the universe are these field stars, these intergalactic stars. They have no home. They're just drifting in space. Now, normally we have the Star Trek planet names that appear above my shoulder, but because this is the last episode before we go on our hiatus, we're not going to do that this week, but I still want to celebrate all the people who voted last week. So thanks to Sorry Dory 78, looking for recommendations on studying astronomy seriously. So thank you for the question. Thank you everybody who voted. And throughout all of the votes that we've done this year, it's always super fun to see what you think is a good question, good answer. All right, let's keep going with the questions. Zostrich 12X. Wouldn't certain types of active galactic nuclei pose as near galaxy-wide sterilization threats to life? So this goes back to the episode that we had 2 weeks ago. That's sort of the way the cycle works, where someone was like asking for a sci-fi novel, definitely not because they're a supervillain, wondering if there's a way that you could sterilize an entire galaxy and not just any single star system. And I sort of brainstormed a bunch of ideas and I couldn't really come up with anything. Well, this is possible. And this is this idea that I mentioned in the previous question, that you can have a supermassive black hole and it can have this accretion disk that is going around the supermassive black hole, and this whips up these giant magnetic fields that twist around the black hole. And then you get material, instead of falling into the black hole, is funneled into these jets. And these jets can be millions of light years long, just going off into space. And you've got material that is moving at relativistic speeds through this jet. And, you know, the research on this is still fairly new. Astronomers aren't entirely sure what the effects are, but it appears that these can do one of two things if they hit a galaxy. One is that they can trigger enormous amounts of star formation. That essentially, this is one of those things that can cause gas clouds to start collapsing and beginning to form stars. And so if you've got this galaxy, it's got lots of puffy gas clouds in it, and then the death beam of a supermassive black hole, just going to sort of goes across this galaxy, you could end up with star formation that is being caused by that. But the other possibility is that you get quenching. So in other words, the beam is so intense that it doesn't actually create collapsing clouds, but it's actually starting to strip away a lot of this material, this light, gas, and dust that's hanging out in these gas clouds. And that starves the stars for star formation. And so both kind of lead to the death of the galaxy, because in the one case, it's as if the galaxy is in an all-you-can-eat buffet and it quickly goes through all of its gas and forms all of its stars, and then it's out of star-forming material, and then it just turns red and dead. And then the other possibility is that it never even had a chance, that it just has all of its material blown away, can never really form a lot of stars, and so it's just undernourished, underfed. And both are very bad for the galaxy. And it wouldn't be like an instantaneous death knell for the galaxy, but when you think about it, to have heavier elements in a star system like we have here in the solar system, the sun needed to have collected elements from many previous generations of stars. That our sun is a third generation star, and it's, you know, little bits of kilonova have been mixed in, little bits of supernovae, stars that have lived and died and blown off their outer envelopes, all that's mixed in with the sun. And so we have all of the heavier elements, all the heavier elements that are around you right now, the gold in your jewelry, the iridium in your chips. All of this came from these, you know, supernovae and kilonovae and things like that. And so if a galaxy ran out of heavier elements early on, it never got a chance to kind of build them up, then it would be really hard for it to form life down the road. And so there's this idea of a galactic habitable zone, places in the galaxy where there are enough heavy elements for life to be able to form. And so if you don't have those heavier elements, then maybe life can't form. And so in the first few billion years of the universe, as these death beams are blasting out of black holes, you could end up with galaxies being not sterilized, but starved. And so they never have the conditions for life to be able to form down the road. So I like that idea. It's pretty evocative. You know, maybe that's your science fiction story, you monster. Alexis ZT6XD, can you please talk about the latest discovery of possible Dyson sphere that was found? Sure. So Dyson spheres. Now, I'm sure you're all very familiar with them, but the gist is that some future civilization is going to need more and more energy, and they're going to continue harvesting energy coming from the sun with solar panels until they look back and go, hey, wait a minute, we've enclosed our entire star in solar panels. Now, it's not going to be some rigid sphere. It's going to be probably a cloud, a swarm of satellites that are orbiting around the star, and they're all collecting sunlight. But the point is that every available photon that is coming from the sun is striking some solar panel and then is being used for some purpose, like, I don't know, some technological purpose, maybe large language models. You can use for AI, you can use for gaming, who knows? And we don't know what the future holds, and it's, maybe it's ridiculous to think that someone will, but it's something to look for. Now, the thing is that when you have all of this radiation that is striking the satellites, they're going to absorb the visible light that's coming from the star, but they have to release infrared radiation. They have to release the heat. They grab the light, turn it into electricity, use it for some purpose, and then they release heat into the universe. And it's that heat that we're going to be looking for. We're going to be looking for point-like sources that are like a star, but instead of them giving off visible light the way a star should, you're looking for them in infrared. And so what the astronomers did was they looked through a bunch of surveys that have been done in the infrared with a bunch of different telescopes. There's the 2MASS survey, there's some Gaia survey, as well as the WISE survey. And these are all able to see into the infrared. And they were looking, they ran all of these stars in the entire survey through a filter saying, is there anything that looks like a star, but it's in the infrared? And they came up with a bunch of candidates, and then they looked through the candidates, removed all the ones that were clearly something else, and they were left with a bunch of things that could be Dyson spheres. So that's what led the paper, the science paper that you're talking about. And we reported on it on Universe Today, and a lot of other people reported on it. And then it sort of kept going and going. I don't want to say we had it first, but we had it pretty early on, in that I saw it in the archive and on the day when they published it, and I tasked a writer to write a story about it. But the chances that these are actually Dyson spheres is really remote. Before you can say that it's aliens, you have to be absolutely sure that it's aliens. And there are other things that can explain this. I mean, there can be problems with the sensors on the telescopes. There can be all kinds of stuff. But one really compelling explanation is a type of thing called a dust-obscured galaxy and a dog. And what these are is fairly distant galaxies that have a large amount of dust in them. And so that dust is blocking the light that's coming from the visible segment of the star. And instead, you're seeing just the infrared heat that is coming from the galaxy. And so you've got this dust-obscured galaxy that is glowing in the infrared, and astronomers went and checked the known locations of dust-obscured galaxies and found that it could explain some of the potential Dyson sphere candidates. And so based on that, other astronomers said it's most likely that you're not seeing Dyson spheres within the Milky Way. You're probably seeing galaxies with a lot of dust in them, so they're shining in the infrared and they're much farther away. So it's exciting. I've mentioned this many times in the past. This is a great way to go looking for advanced civilizations, but don't be surprised if it is more and more difficult to find things like this. Patrick Fritz, with the development of large language models and GPT-type products doing better and better, would you ever consider using AI to help put your articles together and do research? So I have a real love-hate relationship with artificial intelligence, with large language models. On the one hand, they're cool, they're fun to talk to, and they help me brainstorm really cool recipes when I try to think of the things that I have in the house to try and make dinner from. We call that Chef GPT. On the other hand, you've got companies like Google and Perplexity and stuff where they are taking your content on your website and they are cribbing it, and then they are sort of summarizing it, sometimes not correctly, and then making this available to a wider audience. And now people don't have to come to your website, but they require the content that you've created on your website. So that's clearly a problem. But the biggest problem that I have is that they hallucinate and they are not to be trusted. And the amount of time that you have to spend in looking at some article, some content that is written by artificial intelligence, is time that you could just spend just doing the work yourself. So I would never, ever, ever let an AI write any of my content. Never. I mean, I want to say never. If it's better than me, at some point in the future, when the artificial intelligence does a better job than me, then you win, I retire, I will hand over Universe Today to the robots and let them go and do a better job than me. But the question you asked is do I use it for research? And so I don't use it for writing, but I definitely use it for research. And there's a lot of things that it's really good at. Like I'll take like a science paper and I will feed it into, say, Google's Gemini, I'll feed it into ChatGPT, and then, and it's a fairly technical, complicated science paper. And then I will start to talk to the science paper. I'll say, like, what are some of the conclusions? What are some of the numbers that were reached? What are some of the, how many, what percentages and so on of stuff? And then I will be able to double check. So if it makes a reference, I'll look through the paper and make sure that that's what it's saying. And that gives me I'm able to digest science papers a lot more quickly and understand the conclusions that are being made. Because, I'm not a scientist, right? I'm a journalist. And I have to read papers about astrophysics and cosmology and planetary science and astrobiology and all this kind of stuff. And I can't know all of these fields at the same time. And I've found it's been very helpful, but I'm always really skeptical of the results that I get from it. So I think that it's really sad that a lot of websites have gone, big companies have gone straight for, oh my God, we can fire all our writers, right? And then use this stuff to produce sludge. And that's not what the tool is for. It is not, when you have a hammer, everything looks like a nail. It is a very useful tool for helping you understand knowledge when used appropriately. And that's sort of where it sits in my toolkit today. But the pace is accelerating. It's kind of amazing how it's getting better and better and better. And who knows what the future holds. Billy Smith, do you believe that there is a ninth planet? There are some out there who already believe there is a ninth planet. Pluto. I don't have an opinion on that. So is there a planet beyond Pluto? Also known as Planet 9. And this idea came from two very renowned astronomers, Mike Brown and Konstantin Batygin. They were studying the movements of objects in the Kuiper Belt, and they think that they see evidence that there's a distribution of these objects, that some large gravitational mass out in the outer solar system is disturbing objects in the Kuiper Belt, and that could explain the weird distribution. I forget the number now. It's to like 1 in 10,000 chance that there isn't something, according to them. Even so, nobody's been able to find it. And that's not super surprising. We don't have a lot of really big, powerful infrared telescopes, because it's probably going to be a very cool object that can observe wide swaths of the sky and look for anything that is moving night after night after night, which is what you expect to see for Planet 9. So astronomers went and looked in all of the really obvious places, exactly along the planet ecliptic. They've looked in the places that maybe, the astronomers have been able to narrow down the range of locations where this object could be, but they still don't know exactly where it is. And space is huge. When you think about the Hubble Space Telescope, in 35 years of observing, has only looked at about 0.5% of the entire sky. And remember, you would have to look, you couldn't just look once because then you just see a star. You'd have to look twice to see something moving. And you'd probably want a third time. But the telescope that's coming shortly, the Vera Rubin Observatory, is going to come online next year. It is going to be observing the entire night sky every few nights. And it's a huge instrument, the most powerful camera ever built for astronomy. It's going to be able to find Planet 9 if it's out there. Like, if Vera Rubin doesn't find it, then it probably doesn't exist. So I am ambivalent. I have no opinion about whether or not there is a larger planet out there. People think there is. Vera Rubin is going to come along and it's going to find out whether it is. And I think it's best for everybody to hold their opinion until Vera Rubin takes a crack at looking at the night sky. And then and only then will we know whether or not there is another planet or more in the outer solar system. I mean, if anything, Vera Rubin will find all kinds of stuff in the outer solar system. So, I like its chances. Yngvi Freyr. If Vera Rubin doesn't find anything that is planet-sized, would a black hole be the only other explanation? No. The most likely explanation for the perturbations of objects in the Kuiper Belt is some kind of effect from the overall galaxy, that you've got the sum gravity of all of the stars that are moving around in the Milky Way that are somehow causing the Kuiper Belt objects to bunch up in certain ways. Maybe there was a rogue star that moved through, close to the solar system 1 million years ago, and that caused enough of a clustering of objects back at the time. The point is that there are just lots and lots of other ideas to exhaustively look through before you say, well, it has to be a black hole. Now, if it was a black hole, then it's going to be a primordial black hole. It means, because you can't get a black hole with the mass of planet 9 by the collapse of a star. It has to be something else. And it has to be one of these black holes that were formed at the beginning of the universe. And so there have been some proposals on how you might be able to detect the presence of a black hole. I mean, you could see some kind of microlensing as the thing is passing in front of other stars out there, but you have to be watching the entire sky, which there are some telescopes that are coming up that are going to be doing that, like the Nazareth Grace Roman is going to be watching for these microlensing events. There's a survey called OGLE where they're watching for microlensing events. So that could be possible. But also the idea is that if it is a black hole, then it's occasionally going to gobble up a particle in the outer solar system, bits of Kuiper Belt, things like that. And every time that happens, you're going to get a flash of gamma radiation coming from the black hole. And so if you had this telescope that was watching the entire sky in gamma radiation, you might be able to detect the presence of little bursts of gamma ray photons coming from a black hole that is orbiting around the sun. So if it is a black hole, it's still detectable. And so far, nobody has detected a black hole in the outer solar system. RJ, if the Earth didn't spin, if the Earth and planets didn't rotate around the sun, if the galaxy was still, in essence, if nothing moved through space, would there be zero gravity? Gravity doesn't come from movement. Like, if the Earth didn't turn, there would still be gravity. Also, what is turning? Because it's compared to what? You have to sort of think about where you're observing something moving, something rotating. And so, you're not moving compared to your chair, but you are moving compared to the airplane that's flying overhead. And so it's very difficult to talk about something being completely still, because you always have to ask yourself from what perspective, who is asking if something is still. But, if the Earth, for example, didn't orbit around the sun, then the Earth would fall into the sun, because the Earth's actual orbit around the sun is a balance between the speed of the Earth, which is providing an outward force, and the gravity of the sun that's providing a inward force, and you get this perfect balance. And so this Earth is going around the sun. And without the Earth going around the sun part, you would no longer have the outward force that counteracts the gravity of the sun. The Earth would just fall in. If all of the stars in the galaxy weren't orbiting around within the galaxy, they would all just fall down into the center of the galaxy and become a giant supermassive black hole. So, so the motion has nothing to do with the gravity. If you want to support the work we do at Universe Today, consider joining our Patreon club. Your support lets us have a minimum of ads and no sponsorship messages. Patrons get no ads on universetoday.com for life. Want the extra parts of the live stream that aren't in this edited version? You can sign up for a special patron-only podcast feed and get the overtime segments, as well as other special behind-the-scenes episodes, including our monthly patron-only question show. Thanks to everyone who has already subscribed, and welcome to our recent newcomers. Narcoholiker, Max Francis, Stephen Trotman, David Schall, Ren, Special K, Kaidu, Seals McBeals, Lawrence Feenstra, Mr. B, Wayne J2, Abby, and Roger Tolk. Join the club at patreon.com/universetoday. Nadia N. If Betelgeuse happens to explode what's on the other side of the sun from our point of view, would the telescopes we have at L2 notice it, and would they be able to study it from that viewpoint? Oh, that would suck. So, during winter in the northern hemisphere, like during November, December, January, people in the southern hemisphere, I know you exist, is when you can best see the constellation of Orion. It is visible in the night sky. And in the summertime, or I guess winter in the southern hemisphere, during June, July, August-ish, then Orion is behind the sun from our perspective. And so there would be a perfect time for Betelgeuse to explode and it would be lost in the glare of the sun, and that we wouldn't be able to see it. And if we did even be able to see it, then we would only be able to tell for a few minutes sunrise or sunset before it was lost in the glare of the sun. And that would be terrible. But fortunately, Earth-based telescopes are not the only telescopes that we have in the solar system at this point. So now, the telescopes at L2, like James Webb, well, James Webb can't look because it can't look back at the sun. So James Webb wouldn't be able to do it. You've got the Gaia mission. You've got, any of the things at the L2, that's close enough to the Earth. When you think about how you got the sun, the Earth, and L2 is on the far side of the Earth. And so if they tried to look at Betelgeuse as well, they would have to be looking past the Earth at the sun. They'd have the same problem. So L2 isn't going to do you any good. But we have other places in the solar system where there are telescopes. We have spacecraft in orbit around Mars. We have spacecraft on the surface of Mars, Perseverance, Curiosity. And although they are not designed to look out into space, I'm sure if Betelgeuse went off, somebody would be able to task one of them to look in that general direction. We also have New Horizons, which is out beyond Pluto, and would be able to, it has a really nice telescope on board. It would be able to take a look. And there's probably other spacecraft around the solar system, the Solar Orbiter, there's the Parker Solar Probe, like they would be able to do some initial astronomy waiting for Betelgeuse to leave the glare of the sun. But in general, it would be a disaster, because the most important time to look at Betelgeuse going off is in those first few moments when it is going from a red supergiant to whatever are the remnants of Betelgeuse. You want to watch that process happen in real time. And we would have just like an absolute front seat view of the explosion going off. But the other thing we'd also get is the neutrino blast. And we've got neutrino observatories on Earth that would be able to detect the neutrinos that are coming from Betelgeuse. They would go right through the sun, no problem, and they could be picked up. And so we would get that detection. In fact, we would probably get that detection first. Astronomers would get the detection of Betelgeuse going off, and then they'd be like, hey, everybody, Betelgeuse just exploded. Okay, where is it? Oh, it's behind the sun. Oh, no. So I really, really hope it doesn't go off behind the sun. That would suck. MTN Hermit. Do you think we have a second star, a brown dwarf, a small black hole? If we had a second star, we would see it, because it would be the brightest star in the sky, after the sun, of course. So we definitely don't have a second star. Like, we're not in Alpha Centauri with two stars orbiting around each other. Now, could we have a stellar companion that's on an incredibly long orbit that comes by the Earth every 10,000 years? No. We've got really incredible space telescopes like Gaia, which are detecting the position of every star in our vicinity and their motions. And if there was a star that was in some kind of binary system with Earth, it would have caught it, and it didn't. Do we have a brown dwarf that is in our vicinity? And the answer to that is also no. For sure, 100% no. How do we know that? One of the telescopes that I mentioned earlier in this episode is called WISE. And it was an infrared telescope that was launched. And one of its jobs was to scan the vicinity around the solar system, looking for any infrared companions, brown dwarfs. And it did this complete survey of the entire sky, and it didn't see a brown dwarf in the vicinity. And so it was able to rule out the existence of a brown dwarf. In fact, WISE was able to rule out any Jupiter-sized objects within, I'm going to say 50,000 astronomical units, so about a light year away. It was able to rule out any Saturn-sized objects a little bit closer than that. So all we're really left, like when you go back to that answer about Planet 9, all that we're left with that's possible is some kind of Neptune-sized, Uranus-sized object that is within a few thousand astronomical units of the Earth and beyond. Anything closer than that would have already been observed. Anything farther than that that's bigger has been ruled out. And all you're left with is like Uranus, Neptune, Earth-sized objects in the outer solar system. So if Planet 9 is out there, it has to be one of those. Is it a black hole? Probably not. This has been an idea that maybe you could explain Planet 9 as a primordial black hole. but like the chances of it actually being a black hole and not just a planet, like we have tons of planets here in the solar system, are pretty remote. So we don't have a second star. We don't have a brown dwarf. We don't have a small black hole. We might have a Uranus, Neptune, or Earth-sized world, or a few in the outer solar system. Billy Smith, do you like the idea of going to the moon first and then to Mars? Yeah, I am quite against sending humans to Mars first. It's incredibly dangerous. It's very far away. Astronauts are going to have to spend 9 months in transit to get to Mars. They may have to spend up to 18 months on the surface of Mars. Then they're going to have to get in a spacecraft, come back, another 9 months. We don't know how to keep human beings alive in that kind of environment for any length of time. We've barely set humans down on the surface of the moon for a couple of days and brought them safely back to Earth. So there is an enormous laundry list of to-do items that should be done. And we are incredibly fortunate that we have this large moon right next door to us here on Earth, that you can get to and from the moon in a week, that you can communicate in almost real time. And so if people need help or they need something explained or someone has to talk somebody through surgery or something like that, that you can do this. And that there are so many lessons that we have to learn in attempting to live temporarily on the surface of another world, that it really makes sense for us to do them on the moon, which is really close. And, this is NASA's plan. This is the Chinese Space Agency's plan, which is let's go set up some kind of research station on the moon. Let's learn how to work in the lunar environment. And then over time, as we've gathered enough knowledge, then let's figure out how to send humans to Mars. I mean, I totally get that Mars is this kind of romantic vision, that it's this whole other planet and it looks like a desert and it's got an atmosphere, although not very much, and it's got water ice at the poles. It's got all of these interesting things about it. But a lot of our understanding and enthusiasm for Mars comes from our education in science fiction. And that's not the best education. Science fiction can help inspire, but it is doing a really bad job of giving us the realism of what's out there. And so I am, I'm a huge proponent of us sending humans to the moon and to Mars and to asteroids. And why not? Let's go to Titan, but let's do it carefully, one step at a time, safely, building our technology as we go and doing as much science as we can as we get there. One of the big outstanding questions that we have about Mars is, what will long-term 1/3 gravity do to the human body? We don't know. We don't know if it's safe for people to gestate human beings to term in Martian gravity. But if we do a lot of these low gravity experiments on the moon where it's 1/6 gravity, that's even less forgiving. And so if it turns out that we take a bunch of mammals to the moon base and they gestate and they're safe and they're fine, and over long periods of time, maybe there's a cat that lives on the moon base and has been there for 17 years and it's still doing fine, maybe it's even healthier, then we know that Mars will be fine. But until we have that knowledge, it's just not safe for us to spend long periods of time on either the moon or Mars. Sin 6 Grim Reaper. It seems telescopes are making determinations on objects that are one or a few pixels, especially deep objects. How do we know the telescope's findings are accurate and not error or noise? You're absolutely right that many of the objects that telescopes are looking at are single pixels. So any planet that has been directly observed by a telescope, like James Webb or anything, you're pretty much just seeing one single pixel. Any galaxy that's being seen near the beginning of time, you're just getting a pixel or a couple of pixels. And so how can astronomers learn anything from a single pixel? Well, the key is spectroscopy. The key is the light. And so about 100 years ago, astronomers realized that if you take the light from anything, really, if you burn things, then then you take the light that comes from the thing that you're burning and you put it through a prism, you get this rainbow. But embedded in the rainbow, you get these lines, which are called absorption lines. and they correspond to different chemicals that are in whatever it is that you burned. And so you can take some object, you can burn it, you can look at the light coming from it, and you can know what it's made out of. And so just like that, astronomers realized that they could go and look at the light coming from stars, from planets, from asteroids, from galaxies. As long as they're getting enough photons, as long as they're getting enough light, and they are then turning it into this rainbow, this spectroscopy rainbow, then they can actually know what are the chemicals that are in that object. And so they can know that a star has uranium in its upper atmosphere, or they can know that there is carbon dioxide in the atmosphere of a planet that's orbiting around a star that is hundreds of light years away. And spectroscopy is like easily the most important discovery made in astronomy. Maybe there's a bunch, but I think it's hard to argue that spectroscopy isn't one of the most important things, that you can just learn so much by being able to expand the light from something. And so like when James Webb first came online and astronomers started to see galaxies that were just a couple 100 million years after the Big Bang, you got this race to discover what was the most distant galaxy. And you got a lot of really quick observations that were being made where they were saying, okay, we've got, this galaxy is only 230 million years after the Big Bang, and this one's only 310 or whatever. But then they took James Webb and they made these really long, very careful observations so that they could do the spectroscopy, so they could get enough light coming from that galaxy that they could produce the rainbow. And when you produce the rainbow, then you see the absorption lines that are in that galaxy that match a galaxy. And then from there, they were able to tell exactly how far that galaxy had been redshifted away from us. That tells you how old you're seeing that galaxy. And so at any point, like 1 pixel is all astronomers need. Just give them 1 bright pixel and they can tell an enormous amount of information from that 1 pixel. Pete Martinez. So I was hearing about the sun switching its axis. Can this happen? So the sun switches its magnetic poles on an 11-year cycle. So the sun starts out where, imagine, say, the north pole of the sun is at the top and the south pole of the sun, the magnetic south pole, is at the bottom. And then over the course of 11 years, the sun's magnetic field kind of spreads out and gets kind of wibbly wobbly, very confused and complicated. And then it comes back around. And then now, what was the north pole of the sun is now the south pole, and what was the south pole is now the north pole. But it's only the magnetic pole, not the actual physical pole. It's not like the sun flips over upside down. It's just that its magnetic field switches places. And this is a very well documented thing. It's an 11-year cycle. We are actually on our way towards the solar maximum. So we're about to crest, probably in mid-2025, we'll reach the top of the solar maximum where the magnetic field is sort of very strong. We're getting a lot of flares coming out of the sun, a lot of coronal mass ejections, and then things will start to dial back down. And a few years from now, we will get to solar minimum, where there's like no sunspots on the surface of the sun. There's very little coronal activity. We're not getting a lot of these mass ejections. There's not a lot of auroras. And then the activity will build again, and the sun will be in the process of flipping its poles, and then it will, things will pick up again. And this magnetic flip is a thing that the Earth does as well, although the cycle seems to be a lot longer, like something on the order of 800,000 years on average for the Earth to flip its north and south magnetic poles. And I'm sure you're wondering, like, well, is this dangerous? Well, we don't seem to have any mass extinction events that are tied to the same time as the Earth's magnetic pole flips that have happened in the past. So probably not. You probably want to know how we know that the Earth's poles flip magnetically. And so when you have these lava flows, the lava flows can have a lot of iron in them. And as this lava is still molten, you get the little crystals of iron as they're forming. They align themselves with the Earth's magnetic field. And then a later lava flow comes along and maybe the Earth's magnetic field is flipped around. And now the next batch in the lava flow are turned in the opposite direction to match the new orientation of the magnetic field. And so it's a field called paleomagnetism. And so geologists can do a core sample of lava flows, and they can just track each one of the magnetic field line flips in the Earth's history. So it's amazing. All right, those are all the questions that we had this week, that we had this season. So thank you, everybody who put your questions into the YouTube comments and everybody who joined us for the live show. We do this every Monday at 5 p.m. Pacific time. But of course, the next one's going to be in 2 months. So as we get closer, I will put the next event onto the YouTube channel and you can come and join the live show. It is twice as long with lots of extra information. Now, I want to tell you a secret about how you can access the content that we've done. So on our Patreon page, which you can follow us completely for free, when we post the question show, I will also post a link to the full unedited live stream. And so if you want to go and just watch the whole live stream, there's a link there. So all you have to do is just go to patreon.com/universetoday, follow us for free. You don't have to become a patron, and then you'll get a notification every time we release a new episode, and then you can go and watch the full unedited live stream. If you're wondering like how to get that content, this is the way to do that. Now, I'm going to talk about a book in a second, but I'd like to thank our patrons. Thanks to Abe Kingston, Adam Schaefer, Andrew Gross, Bill, David Giltonen, David Matz, Dennis Alberti, Dustin Cable, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Modso, Paul Rohrbach, Stephen Krasaki, Stephen Fowler-Munley, and Vlad Chiplin, who support us at the Master of the Universe level. And all our patrons. All your support means the universe to us. All right, so I've got a new book series that I have begun, and this is The Machineries of Empire. And, you know, many of you know that I really like the kind of grand, sweeping types of science fiction, space exploration stories, like the Culture series, like Revelation Space, Mass Effect, you know, dealing with empires that have been around since the dawn of time, and humans venturing out into a cold, unfeeling universe. So so now I'm reading this book called The Nine Fox Gambit by Yoon-Ha Lee. And this is the first book in the series, and there's 3 total. And it is really weird and really complicated, but it is also tickles a lot of the same kinds of, entertainment that the Culture series and the Revelation Space do. The book is about a military leader who has to defeat an enemy in space, and she makes the recommendation that they bring out of cold storage one of the greatest generals that was ever in their empire, but was also a mass murderer. And so he's a very dangerous guy, but he's really tactically good. And yet he doesn't remember why he wiped out his whole army. And she agrees to have his personality implanted into her mind while she attempts to win this battle. And he is her advisor, but also, it's kind of dangerous. So anyway, the writing is very good. The concepts are sort of in that same vein as the Culture series. Very complicated technology. You're trying to kind of wrap your mind around how this universe works, and it's very satisfying as you make progress in the book. So check out The Nine Fox Gambit by Yoon-Ha Lee. All right. We'll see you next season.